Hello children, let us solve another example. Again, thought-provoking example, but comparatively easier. Okay. A figure is given in which it is said that segment FD is parallel to segment PC, and the question says prove that the product of these three ratios is equal to 1. So let us start. In triangle BFD, let us separate the triangle from the original figure. Okay, this is B, this is F, this is a D, and this segment CP is parallel to FD. So from the original figure I have separated the triangle. In last many examples what we have seen that we have been showing that the triangles are similar by AA test, but here the ratios which are given in the required result are such that you can directly use BPT. Okay, so in triangle BFD, segment PC is parallel to segment FD. We have written segment PC is parallel to side FD. This is already given. Therefore, by basic proportionality theorem, we can write BC upon CD is equal to BP upon PF. So we have written that BP upon PF. But what I observe that we want BD, B to D, and what we have calculated is BC to CD, BC upon CD. So if you add this CD to BC, BC plus CD will give you BD. BC plus CD will give you BD. That means the denominator needs to be added to the numerator. That means we have to use component. Now this decision making you can get only by continuous practice of problems. Okay. So we have added CD to the numerator. So on the right hand side also we have to add PF to the numerator, which we did. But BC plus CD is equal to BD. BC plus CD is equal to BD. And same way on the right hand side, BP plus PF. BP plus PF will give you BF. So we have written BF, for which we have given the reason as betweenness. That means the first ratio which is there in the required result we have obtained. CD can be written as a DC. Why did I write so? Because it is so in the required result. So BC plus CD is written as BD, CD I have written as a DC, and BD upon DC, this ratio which I needed in the required result, I have calculated and kept ready. Now I am shifting into another triangle APC. Again, if I draw that triangle separately, it looks like this. This is A, this is P, this is C, and this is the segment FE, which is parallel to PC. So we have written segment FE is parallel to PC. These two segments are parallel. That has already been given to us. And therefore, again you can apply BPT and you can write AE upon EC is equal to AF upon FP. Correct? But what I needed in the required result is not AE upon CE, CE upon AE. So I took the invert endo of this and I got the result. By invert endo, the reciprocals of both the sides will also be equal. So CE upon AE is equal to FP upon AF. So that gave me the second result. First I have obtained in equation 1. Second I have obtained in equation 2. Let us multiply these two. That means we are not going to get this ratio. We will multiply these two and let us see what do we get. Now this is something, again I am telling you, this is something which you will have to memorize. Remember that if you do so, you get something on the right hand side which will in turn give you the required result. So I multiplied the two ratios which I have calculated. BD upon DC here multiplied by CE upon AE here, because that is what we want in the result. So will get the product on the right hand side as equivalent of BD upon DC is BF upon PF. I wrote BF upon PF. Equivalent of CE upon AE is FP upon AF. That also I have written. So this PF and FP is the same segment. They will cancel each other. What you get is BF upon AF. BF upon AF. Now, if I cross multiply this, AF will go in the numerator and BF will go in the denominator, and that is what I have done. AF I have transferred here and BF I have transferred in the numerator, but BF I have written as FB. Segment BF and FB is the same segment. Okay, so this ratio, when you transfer cross multiply, it comes in the third position, and on the right hand side what do you get? You get equal to 1, because AF will go to the numerator, FB will go to the denominator, and what will be left on the right hand side is 1, and finally what you have got, the product of three ratios is equal to 1. So easier example, but again none of the examples are difficult unless you get the track of solving it, and suddenly getting the track is always difficult. If this example appears in the examination and you are facing it for the first time, it is very difficult to get the track, okay, for which you need continuous practice. Thank you, girls.